Hi all, my name is Yas Rahmat. I am from Kerala. Today I am taking a class on the types of cement used in reinforced cement concrete. We know the reinforced cement concrete is an important and most popularly used material in construction industry and civil engineering field. And the most popular word we used will be reinforced cement concrete. How it is produced? Reinforced cement concrete. First of all, we need to discuss cement concrete. Cement concrete is a mixture of aggregates, cement, water, and a little amount of air entrapped within, small amount. We know, first of all, cement and water will generate a slurry and it will fill within the voids within aggregates. Aggregates we can basically classify into two types. First one is coarse aggregate. Second one is fine aggregate. Coarse aggregate will be greater than 4.75 mm size. Fine aggregate will be less than 4.75 mm size. And as we discussed, cement and water will generate a slurry. It will fill the voids within fine aggregates, and the mixture of cement, water and fine aggregate generate the product, which is a mixture of cement, water and fine aggregate, known as mortar. And this mortar will fill the voids within the coarse aggregate, since the coarse aggregate's size will be 4.75 mm, will be greater than 4.75 mm. As we know, cement concrete is the only material which is manufactured or prepared on the site itself. The other materials like structural steel, wooden materials will be, we can get this one is ready-made, but the cement concrete will be 90% of cement concrete will be mixed or prepared on the site itself. Little amount of cement concrete will be ready within precast or something like that, but 90% of the cement concrete will be prepared within the site, and 30% of the total cost of the building will be from this reinforced cement concrete. If it is a permanent construction, the 70% of the total cost of the construction will be by the concrete structure, reinforced cement concrete. Then it is important as working out the structural designing as we know the concrete is weak in tension but strong in compression. Concrete is weak in tension but strong in compression. Then we need to strong in tension also. Hence we adopt the reinforcing by a material which will be strong in tension also. That I used steel or fiber or something else. This method will be effective in strengthening the weakest point of the concrete also. Okay. Then next point will be the strength of the concrete is governed by the properties of its constituents and its proportion, therefore desirable to study the properties of its component. The components are aggregates, cement, water. Now the most important component of the cement concrete is cement. Cement is the binding material between these aggregates. We know well the cement is prepared by mixing and grinding the materials, that is siliceous, argillaceous and calcareous. Cement is produced by mixing and grinding the siliceous and argillaceous and calcareous materials, and the clinker will be cooled and powdered in a fine format. Cement is produced by mixing siliceous, argillaceous and calcareous material, and it will be burned in a temperature of 1400 degrees Celsius and cooled and powdered. We are getting the cement in a powdered format. The main components of the cement is 60 to 70% lime, 17 to 25% silica, 3 to 8% alumina, 0.5 to 6% iron oxide, 0.1 to 4% magnesia, 0.2 to 1% soda and potash, 1 to 2.75% sulfur dioxide, 0 to 1% free lime. Now we are discussing about the types of cement. Now we can get different types of cement, which is classified according to the strength of the cement, workability of the cement, color of the cement, and uses of the cement, and mainly it is classified based on the components and different proportions of the components within the cement. First type of cement is ordinary Portland cement, OPC. This is the most commonly used cement for normal concrete construction. Most commonly used. Just have the components, which one we have already described: lime 60 to 70%, silica 17 to 25%, alumina 3 to 8%, iron oxide 0.5 to 6%, magnesia 0.1 to 4%, soda and potash 0.2 to 1%, free lime 0 to 1%. And different compounds used in preparation of OPC was one, tricalcium silicate, that we called C3S. Next, dicalcium silicate, that we called C2S. Next, tricalcium aluminate, that is C3A. Next one is tetracalcium alumino ferrate, C4AF. These are the four compounds which is mixed on different proportions according to the strength we wanted with this type of cement. Then we have to discuss the properties which have given by these compounds. to the cement. First, C3S, that is tricalcium silicate. Tricalcium silicate, which decides the strength of the cement. Tricalcium silicate, which decides the strength of the cement, and which gives the durability for cement, and which help to hydrate the cement rapidly. Next, this compounds attacks the effect of acids and alkalines. Next, C2S, dicalcium silicate. Dicalcium silicate is the strength giving compound after 7 days. Next, C3A, tricalcium aluminate, which helps rapidly setting, which helps to resist effect of alkalis and salts. The second type of cement is rapid hardening Portland cement. We know the purpose of this type of cement from its name itself. Which one is used to get the hardening of the concrete rapidly. This one is getting by different chemical composition of these 4 items: tricalcium silicate, dicalcium silicate, tricalcium aluminate, tetracalcium aluminoferrite. And by this have the degree of burning and degree of grinding will be different to OPC. By this, the burning and the grinding will be different to OPC and getting rapidly hardening Portland cement. And this have lime component high. Lime is getting high. This also affects the rapid hardening property of the cement. The degree of burning will be defined by short time burning and finer grinded particles. And with respect to the compounds, higher level of C3S used for reducing the initial setting time. Higher level of the C3S will be used, and by using this cement, this rapid hardening Portland cement gets the strength which one is gets for OPC in 7 days will get to the rapid hardening cement in 3 days. 3 days will get OPC's 7 days strength, and RHPC's 7 days strength will be OPC's 28 days strength. By using this type of cement, we can remove the shuttering very rapidly, and we can reduce the cost of the formwork and shuttering, and this will give a satisfactory condition on frost effects. I believe you get this. Next, third one is low heat Portland cement. As we know, by mixing the cement and water, the hydration takes place, and by the effect of this hydration, lot of heat is produced, and this heat will gets lost by the surface of the cement concrete or cement structure. If the cement surface which will exposed to the atmosphere is very much low respect to the total mass of the cement, the total loss of the heat produced by hydration with respect to the total heat produced will be very high, and this heat will make a reason for water tightness and deterioration of the cement, and this water tightness will generate a shrinkage in the concrete, and it will generate the crack within the concrete. There is the efficiency of the low heat Portland cement is found, which one is used for mainly mass concrete structures like dams, abutments, etc. This one is used for cases like the heat released through the surface will be very less than the heat produced by hydration. We said on the starting is mainly used on the cases on the massed concrete structures where will be the heat released through the surface of the concrete will be very much less than the heat produced within the concrete by hydration, and this will affect the water tightness and deterioration. And the cooling of the concrete will generate a shrinkage. We are producing low heat Portland cement by controlling the compounds used in this cement by tricalcium silicate used is low. This will cause initial strength of cement, concrete, and we are increasing C2S, which accelerate reduce heat produced. And C3A also decreasing. By using this cement, we can reduce the 80 calorie per gram. This one is the heat energy generated by OPC to around 60 calories per gram low heat. Next, fourth type is Portland Pozzolana cement. Pozzolana have no quality or no property of increasing the strength of the cement, but pozzolana can affect for reducing the free limes in the cement. Free limes are the weakest point on the cement, which can directly attack by alkalis, salts, and other chemical minerals. This can be removed, or this can be make a stable limes by mixing and grinding the pozzolana within the cement. For the optimum strength of the cement, we have to proportion the pozzolana used in this Portland cement. Usually it will be 10 to 25% of the weight of the cement. This one is mainly used for, as we say, for stable lime. Stable lime will increase the strength by reducing the chemical attack on this cement. This type of cement is mainly used in seawater constructions. Next, white cement. White cement is directly same as OPC, and for making this, to remove the color of the OPC, we have to reduce iron oxide content on the making. This one is in white color and mainly used for decorative works in the construction. Next one is colored cement. Colored cement is same as white cement. White cement will be the base for this colored cement, and it will add with some pigment giving materials. Next one is sulfate resisting cement. This one is mainly used for resisting the sulfate attack on cement. In western arid regions in India, the groundwater deposit lot of sulfate content, and it will affect the strength of the cement used in concrete or mortar. This can be resisted by sulfate resisting cement. It will produced by tricalcium silicate, will be 5%, less than 5%, and a different proportion 2C3A, 2 tricalcium aluminate plus tetracalcium aluminum ferrate will be less than 25%. Next type, on another type, hydrophobic cement. This is a new generation cement which can be used for transportation or other purposes by resisting the water content or atmosphere water before the main use or before using for manufacturing of concrete or mortars. This one is making by adding water repellents on the cement production, and this water repellents will make a water resistant monomolecular coating around the cement particles, and it will resist the effect of water content and resist the hydrating. Before using for concrete or its cement's purpose, by abrasion this molecular coating will be removed, and by adding water the hydration takes place. Okay, these are the cements mainly used in construction industry, and hope you got an idea about different types of cement used, and I am signing off. Thank you for listening. Have a nice day.